Good morning and welcome back again. Today we are going to finish chapter 13. It's talking about arc length and some things. If you remember in 13.2 we say if you have vector valued function, how to find the derivative and limits, right? And as well we used integral. So today, if you remember all this together, and today we are going to say something else about length. If you have vector valued function, how to find the length of them in the space. You can see from here, here's the space that we have, and we will try to find the length of them. So look at here. Of course, you have R is a function that contains something, any function. For example, h of x, I, g of y, or g of x, j, plus m of x, k, where h, g, m are functions like that. For example, xi, x squared, j, square root of x, k. Is that clear? Yes? Good. So, in that case, we say R is a function with a value. Good. Now, what else? What we have? Look. How we find the length? Because I have an arc, a path, I want to find the length of here is equal to L. So how we find them? Of course, this curve, the curve L, or let's say C, is any curve in 3 dimensions. Okay, Kaka? In 3 dimensions. So how we find them? You know, for example, if we have a 2 dimensions, we say that we are going to use Pythagorean. You remember, you make here is x, delta x. If you remember, of course, at the same time we have delta y, and we say we are going to find the Pythagorean. The hypotenuse will be the length that we have. The same thing is true for here. Delta x, delta y, delta z that we have. Of course, you know, this is y and f and z. Clear? Good. So, this is the general, what do you say, general form, and that one specific form or the short form. Then we have what? How to find them. The best thing to understand, the better things to understand, if you have a function, how to find what? The path. How long the path that you have. Path means that length, curve. Long means that length, right? So, how we find the length? As we say, we have an integral L from A to B. A to B. A to B is what? Is that, you know, we have a T. T is about the parameter that we have. So T should be start from T0 to T1 or T1 to T2. We should count everything here. And the time is given from 0 to 2 pi. So just means that solve the integral. So when we have a length, do not forget about that we have integral. Of course, we have that shape and surface also length in the other chapter. So do not mix them. Now we say from 0 to 2 pi, this is delta x, this is delta y, this is delta z. You can know derivative of t equal to 1, derivative of sine equal to cosine by minus, derivative of, is equal to cosine, derivative of cosine is equal to minus sine square, and each one is square. So I know sine square, cosine square is equal to 1. Is that clear? So it's equal to 1 plus 1 square is equal to 2. Understood? Anything? Hello? Good. Now, of course, Don, you know, if you have this one is equal to 2 dt, the result will be 2t, and t can be substituted from 0 to 2 pi. So by default, I get what? 2 pi minus 0 طبعا. Clear? Any question? Is there anything not clear, Jamaat? Sine square, we have a rule. Sine square t or theta or x plus cosine square of t or is equal to 1. This is the identity, okay? This is the identity. Question. So it means that today we have just only to count integral. Another thing we have is parametric length. How to find parametric length or arc length parameter. What do you mean by that? The same thing that we have, Kakija. But instead of RT, we have ST, and we need to find relation between S and T. This is your duty. You need to find the relation between S and T. The same rule that we say before. You can see from example. Find the length of parameterization curve if T naught is equal to 0, and the arc length of parameter helix is like that. So, find what? Length parameterization. When I say length parameterization, we say that instead of RT, we are going to use what? ST. Is that clear, dear? Look at the rule. What's the difference between that and that before? Before we have what here? Hello? In the previous example, what we have? Good morning. We say length, right? L. Look. How about other difference? We have T, in CT we say AB, means that we have a numbers. How about here? T naught, number T. T is what? Is variable. That's why it's called parameterization length. If I say f of x equal to 2x, that's okay. How about if I say xt is equal to t squared, and f of x is equal to what? On t between 0 and 1, and f of x is equal to what? F of x is equal to, for example, x. So you say this equation, because equal to t squared, means that because t between 0 and 1, this function is called what? Parameterization things, Clear or not? Jamaat. Your face expression says something else. Clear? Good. So parameter means that we have something is movable, as we say, like a water and steam. Between them you have a heat, right? Called something like that. So what's the difference between this arc length with the other one? The first one, it was length given AB, means that T1, we have T1 also a number, and we say is equal to delta X, delta Y, delta Z. Do you remember that? dt, am I right? And each one is function with t. Good. How about the other one? We say st equal what? From number to variable, the same thing that we have here, dt. Then we get what? We get st is equal to something t. Something t. Why something t? Because this one is not given. It's parameterization. And maybe t between 0 and 1. We said something like that. And later on, this is the first step. The second step, you need to find the relation between t and s to put it in RT. Write this note, please. Okay. Now, you observe, you found that there's a relation between RT. Sorry, there's a difference between L and ST. Is that clear? Good. Now, here's the example. You see what? You have T naught. Where is T? Where's T1? Where is B? We have A, B. This is A, the given. Where's B? Not given. So it means that B equal to T. And he say what? Find length parameterization. So it means that I want to find ST. Is that clear? Good. So I say ST equal to طبعا the same function. I will get what? The same result. Am I right? Hello? Good morning. Same example like straight away. Look. حد معنا كده سابيكو cosine sine t. Kawata. We have cosine sine t. Of course, I'll get what? Square root of t. But what's different? When I substitute, I got st equal to something t. Now find. This is the first one. We got in our example. First step is st equal to square root 2t. Now, second step, find the relation between what? T and S. How? I say T equal to what, Jamaat? Huh? T equal to what? Anybody home? Kazleria? T equal to what? Am I right? Really? T. How you find the T? I know. Now, I say what? RT, it was about cosine, right? Will be changed to what? Is that clear, Jamaat? Hello? Ayabachi, Hertia Gabachi. Why? Because there was a relation between S and T. Good. Another thing is called unit tangent vector. In a vector valued function, if I have something like that, I want to find tangent. Tangent is what? Derivative. Am I right? Tangent is derivative. First derivative. In calculus 1, high school, you heard about that one. Also in Cal 2. So, here's T capital, it's called tangent, and this is V means velocity. What was the velocity in 13.2? First derivative, acceleration it was what? First derivative of r. Acceleration it was second derivative of r. Do you remember that? Good. So, what's your duty? If I gave you r, you are going to find first derivative. Clear? Then length of first derivative, lengthy area equal to what? Lengthy area. Here's square. Here's square. Here's square. Am I right? Good. So I got what? Sine. If you take 3 as a common, look. We say RT equal to 3 cosine T. 3 sine T plus T square. Taking a derivative, I get what? ليه جمعت? We got minus 3 sine t I cosine tj 2tk. Am I right? How about length of v? Here's square. Again, here's square. Am I right? Good. Between here and there, we have common. It's equal to what? جمعت 9. Wanya? So 9 come out, and I'll get what? 9 sine square cosine square. Am I right? And that one equal to what? 1. So that's why V is that one. And we say T is equal to what? V over V. It's called unit tangent. Unit tangent. Why unit? Because we know that each vector over its length, it will be unit vector. Then clear? Sine, cosine. This is all about chapter 13. Do you have any question?